Hello students. Today we are going to solve a question from oscillation. Okay, and this question basically asked in TIFR 2022. In that question, they have given that an electron is set oscillation by the action of electric field of laser. Okay, and the intensity of laser is given. The intensity that is given on 50 watt per meter square. Also, they have provided the wavelength of laser light, lambda. Okay, so that is given as 554 nanometer. So then they ask, we have to calculate the amplitude of oscillation of this electron as well as its speed during oscillation, that we have to calculate. Okay, let us solve. So first of all, we'll calculate that amplitude of electric field of this laser beam. So we know this relation, that intensity of laser beam is nothing but 1 by 2 times C into epsilon naught into E naught chi square. So this is the E naught, that is the amplitude of electric field of this laser beam. Okay, from here I'll get E naught, and that will be square root of 2I divided by epsilon naught C. Okay, so if we calculate this value, E naught will be simply 2I is given, that is 150. Then epsilon naught, that we know, epsilon naught in SI unit, that is 8.85 into 10 to the power minus 12. Okay. Then you have C, speed of light, that is 3 into 10 to the power 8. Okay. So this is all actually inside that square root. Okay. So from here, if you calculate this value, you'll basically get that value 3.36 into 10 to the power 2 meter. Okay. Now we'll calculate that frequency of this electric field or frequency of this EM wave. So we know omega is nothing but frequency, angular frequency omega is nothing but 2 pi nu, and nu is nothing but C by lambda. Okay. So 2 into 3.14 into the speed of light, that is 3 into 10 to the power 8, and lambda is given of this laser beam, that is 554. So in meter it will be 554 into 10 to the power minus 9 meter. Okay, so if you calculate this value, basically you will get 3.4 into 10 to the power 15 per second. Okay, or second inverse. Okay, so we have obtained this frequency of oscillation of this electric field of laser beam, as well as we have calculated that amplitude. Okay, 3.36 into 10 to the power 2 meter. So I can write that electric field component of this EM wave of laser beam, that will be E naught. Okay, E naught we have calculated. Then I can write sine omega t minus kz. Okay, let us assume this beam is actually traveling along z axis. Okay, just I have assumed. I have calculated that value E naught as well as omega. Okay, now that force experienced by this charged particle electron by the action of this electric field of laser beam, that will be how much? From Newton's law or Coulomb's law, I can write F equals to how much? Q into E. And Q is the charge of this electron, that is minus E, right? And E can be written as like this. I can write E naught sine of omega t minus kz. Okay. And force is nothing but m dv by dt, right? So I can write me, mass of electron, dv by dt, that should be equals to how much? Minus E naught, okay, and sine of omega t minus kz. Okay. So it means what I can write that dV by dt will be how much? E naught by me sine. So if we integrate both sides, if I keep that me this side, okay, and if I integrate both side, okay, by keeping dt this side, basically I'll get that velocity or oscillating velocity. So you will have this component that will be E naught by mass of electron, right? And then sine, integration of sine, that is cosine omega t minus kz, cosine omega t minus kz. But you have to integrate or you have to differentiate this part also, right, on the denominator with respect to time. So if you differentiate, you will basically get omega. So this is the maximum amplitude of velocity of oscillation of this electron. So you can clearly notice that velocity is oscillatory in nature. Velocity of this electron is oscillatory in nature, but maximum value of velocity will be how much? V max. That will be this amplitude, right? So this will be electronic charge 1.6 into 10 to the power minus 19. Then E naught that we have calculated, that is 3.36 into 10 to the power 2 divided by mass of electron, that is 9.1 into 10 to the power minus 31, okay, kg. Then omega, that is we have calculated, omega was 3.4 into 3.4 into 10 to the power 15. Okay, so if you calculate that value, basically you will get V max that I have calculated 1.7 into 10 to the power minus 2 meter per second. Okay, so this is the velocity. This is the velocity of this electron when it is oscillating. Okay, now we can calculate that displacement also. So since we have obtained that expression for velocity, and velocity is nothing but dx by dt. So that should be equals to how much? That is equals to minus E naught and sine of, this will be your cosine factor. Okay, cosine omega t minus kz. Okay, so if we keep that dt this side, okay, and if we integrate this, basically we'll get that displacement as a function of time or oscillatory displacement. That will be how much? This side you have this part also, me omega, right? So this will give you minus E naught divided by me omega square, and then you will have this component sine omega t minus kz. Okay, so what will be the amplitude? This is actually the amplitude of oscillation. So amplitude will be E is nothing but 1.6 into 10 to the power minus 19. Then you have E naught that we have calculated 3.36 into 10 to the power 2, right? Mass of electron, that is how much? 9.1 into 10 to the power minus 31. And omega we have calculated, that is 3.4 into 10 to the power 50 square. Okay, so basically if you calculate this value, I have calculated, so we'll get 5.1 into 10 to the power minus 18, okay, in meter. Okay, so velocity, that was 1.7 into 10 to the power minus 2 meter per second, and amplitude, that is 5.1 into 10 to the power minus 18 meter. Okay, so according to that given option, correct option, they have said that correct option will be yes. Okay, thank you.